So let us just have a recap of what we saw in our previous session or the last session. So we first of all, before the last session also, we were discussing about the classful address mask and how to calculate the network ID and the broadcast ID of the classful address mask. And then in the last session, we discussed what are the issues with the classful address. So so issues with the classful address mask is if we follow the classful address mask rule, where the class of IP address, for example, class A, B, and C, they should have their respective address mask of, for example, for class A, it is 255.0.0, class B, it's 255.255, class C is 255.255, 255, right? So if we follow such rule, right? So for class C, it's not a problem, but majorly for class B and class A, it's an issue. So I took an example of class A where let's say that the a customer comes to the ISP and he says that I need an IP address where it starts with 10, right? And I need only 500 IP addresses. So he will assign a class A IP address with an address mask of 255.0.0.0. So if we know that in a class A IP address, there are 24 host bits. So the IP addresses that he can have is around 2 power 24, is around 2 power 24. Now he needs only 500 IP addresses, but 2 power 24 IP addresses is around crores. Right. So what about the other IP addresses that are basically wasted? And not only that, the customer is paying for this 2 power 24 IP addresses, which he's not going to use also. Right. So that was one of the problem with classful IP address, meaning that if you assign one particular IP address to a particular customer, it gets assigned to him. When it gets assigned to him, he has to pay for it, right? He has to pay for the IP addresses that he has to use, and he has to pay for the IP addresses that he will not be using also. So in a class A or class B IP address scenario, this is a huge problem, right? Because in a class C IP address, you have 2 power 24 host bits, and in class C, you have 2 power 16 host bits, right? Which is a huge number, and probably the customer may not need so many IP addresses as a problem. So we came for a solution where we say that I will give you IP addresses as per your requirement, but I'm not going to follow the classful address mask rule. Classful address mask rule says that classful address mask means that whatever class you choose, class A, class B, or class C, their respective address mask, if it is chosen, it's a classful address. If you do not follow this rule, it's basically a classless IP address, meaning that for a class A IP address, I can use a class C address mask. Okay, so for example, I have here, let's say 10.0.0.0 is a class A IP address, right? And instead of the class A address mask, that is 255.0.0.0, I'm using 255.255.255.0, which is a class C address mask. And hence, this is called as a classless IP addressing, right? So in a classless IP addressing also, you can have, again, you can have the range of IP addresses. You will have a network ID, you will also have a broadcast ID, and you will also have the usable IP addresses as well. Okay, so we discussed that why was it required, and also we discussed how to calculate the network ID and how to calculate the broadcast ID and the usable IP address range for a classless address mask as well. Okay, and then we discussed that with a class in real time we may not find IP addresses that are looking like 255.0.0.0, may not be looking like 255.255.0.0 and 255.255.255.0. We may not see such IP addresses in the real time also. We may see some other numbers other than 255. And what are those numbers? We also discussed that. And those numbers were these numbers: 128, 192, 224, 240, etc. Right? And we will see only these numbers only in the address mask. No other values we will see. And the reason for choosing these numbers strategically is because If you remember, I had mentioned that the networking devices see the address part of an IP address to the number of ones in the address mask. Okay, let me repeat that. Any networking device sees an address part, so no, sorry, the network part and the host part of an IP address from the number of ones and the number of zeros in the address mask. Okay, so the first time when I said IP address. The second time when I'm saying it is address mask, not IP address. So over here. Okay, so if I write, for example, if I take this particular IP address, or not IP address, this particular address mask. Okay, 10.1.2.3. Okay, and I write the address mask as 255.255.192.0. Okay, we know that in 255 we have 8 ones. Here also we have 8 ones, and in 192 we have 2 ones. Okay, so a networking device will see how many network parts are there in this particular IP address based on the number of ones that are in the address mask. Okay, and why does it need to find out the number of ones? Because as per the networking, as per the IP address rule, all the ones, in an IP address mask should be on left hand side, and all the zeros should be on the right hand side. So here you see there are 3 examples. All the ones are on one side and all the zeros are on the right hand side. Here also zeros are on right hand side, ones are on left hand side. And you will notice that all the ones are together, all the zeros are together. Here also all the ones are together, zeros are together, ones together, zeros together. Okay, so that means all the ones should be together, zeros should be together in the address mask. You cannot have interleaving ones and zeros in the address mask. This is not an address mask. Why? Because as I said, the networking devices find out the address. They find out the network part and the host part with the zeros and ones. So he will see this as a network part, and he will see the networking device will see this as a host part. But with this particular address mask, it will be confused. It will see this is a network part, host part, network part, host part, network part, host part, then again a network part. So this is confusing, right? So it was strategically chosen that these numbers from 0 to 255, from 0 to 255, these are the numbers that will be seen or chosen or used to write an address mask. Okay, it may not be just 255. You can have IP addresses like 255, 255, 192, 255, 255, 255, 240, 255, 248, 00. And in all these numbers, all the ones are on left hand side and all the zeros are on the right hand side. And also you cannot write an IP address like this 255.0.192.0. No, you cannot write an IP address like this. That's not the correct way. Okay, so we saw why we choose such numbering as well, right? And then we saw what is how to find out the subnet part and the network part and the host part in an IP address. Okay. So in an address mask, the total number of ones is also called as a prefix length. Total number of ones in an address mask is called as a prefix length. The total number of network bits is called as, we denoted as n bits. Total number of host bits is h. Total number of subnet bits is s. Okay. Now, what is this subnet? Okay, we understood what is a subnet. The zeros in the actual address, which are converted into ones or which are changed into ones, they are the subnet bits. Okay, this is what we had learned in our previous sections, right? So whatever zeros in the address mask, you convert them into ones. Those bits are called as subnet bits. And the total number of ones, the total number of ones, which is basically p bits, which is basically the prefix length. This prefix length is basically a sum of prefix length is basically a sum of your network bits plus your subnet bits. Okay, the network bits is nothing but the bits that are based on the classes. Class A has 8 bits, so 8 network bits. Class B has 16 network bits. Class C has 24 network bits. Other than these network bits, whichever zeros of the host part are converted into ones, they are called as subnet bits. This is what we had learned in our last class. Okay, so continuing with that, let's jump into few scenarios. Okay, where we will have to calculate the p bits, we will have to calculate the network bits, we will have to calculate the host bits, we will have to calculate the subnet bits as well. Okay, so this is the first example. Let's go through that. So he says, find out the p bits, network bits, host bits, and the subnet bits for an IP address 8.1.4.5 with an address mask of 255.255.0.0. So 8.1.4.5. Address mask is 255.255.0.0. Okay. So the total number of ones or the total number of p bits, okay, or the prefix length as we see is based on the address mask. So we know that here it will have 8 ones, plus here also it will have 8 ones. So the number of p bits or the number of total number of ones in the address mask is 16. All right. Now, this IP address, we know that this is a class A IP address. And in a class A IP address, how many network bits or how many network octets are there? There is only one network octet. So network bits will be 8 bits. 8 bits. Correct. So, okay. So we know that P bits, okay, or your 16 bits is including your 8 bits plus your subnet bits. So his subnet bits here is again 8. The extra 8 bits that you're having, extra ones that you have, which is the subnet bits, are also S, are also 8 in number. So you have 8 network bits and 8 subnet bits, totaling your prefix length to 16. So you have 16 number of ones like this. Okay, I hope this is clear. Right. So your S bits are 8 in number. Now the next thing is how many subnets are present. Okay, now we have to find out how many subnets are present. Okay, so the total number of subnets. Okay, so we are actually, as I said, we are dividing a big network into smaller networks. Okay, this is a big network of 8.0.0.0 network, that is 8.1. We are dividing this 8 network into smaller subnets. And how many such smaller subnets can be? That is based on the subnet bits that we have calculated. And the total number of subnets that we can have is 2 power s. And as per this, we will have 2 power 8. Okay, which is basically 256 subnets. So we are dividing this 8 network into 256 different or smaller subnets. All right. Now, so we have P is equal to 16. Total number of ones that we have is 16. Obviously, so in an address mask, you have ones and you have zeros also. Zeros denote the number of hosts, correct? So if you have 16 number of ones and our IP address is a 32-bit number, and out of this 32 bits, already we have 16 bits of ones. So the host bits or the number of zeros will be 16 number of zeros. And how many hosts can we have? That is calculated as 2 power h minus 2. 2 power h minus 2. So it is basically 2 power 16 minus 2 hosts can be present. Now we calculated 256 hosts, sorry, 256 subnets. Each of these subnets, you can see here, this is a big network of 8, big network of IP address, which starts with 8. We have divided this big network into 256 smaller subnets. And each subnet, that we have divided will contain 2 power 16 minus 2 IP addresses that we can assign to the users. This guy will also have 2 power 16 minus 2. This subnet will also have 2 power 16 minus 2. This subnet will also have 2 power 16 minus 2 hosts. Hosts are, as we had discussed, host part is the part which we can assign to the users. So each subnet will have 2 power 16 usable IP addresses. And why is it a minus 2? I have mentioned minus 2 over here, minus 2 over here. But why is it a minus 2? The minus 2 is because network ID is one of the IP address that I cannot assign, and a broadcast ID is the next IP address that I cannot assign to a user. These two do not count as a usable IP address, and hence you see a minus 2 over here. So when you are subnetting, okay, you will have number of subnets, and the number of subnets is based on the subnet bits, and the subnet bits is calculated as 2 power s. Okay, and each of these subnets, okay, whatever value you get, let's say 2 power, let's say you get 8 subnets, for example, you have 8 subnets. Each of these 8 subnets, subnet number 1, subnet number 2, subnet number 3, subnet number 4, etc., each of these subnets will have 2 power h minus 2 hosts. Subnet number 1 will have 2 power h minus 2 hosts, 2 power h minus 2 hosts, 2 power h minus 2 hosts in each and every subnet. All right. Any question or any doubts you have understanding this part?
Yes, sir. It's a formula 2 power n, right? For calculating the subnets.
Not 2 power n, 2 power s, the subnet bits.
Okay.
Okay, so let me again, because you were not there, let me tell you. See over here, our IP address that we have chosen, or this IP address is 8.1.4.5, correct? And
Yes.
this is a class A IP address, correct? And
Okay.
as per the class A IP address, the address mask is 255.0.0.0, right?
Yes, sir. Understood.
Now, here he has mentioned the address mask as 255.255. 0.0. Okay. So this is anyway your network part. This is your network bits. So how many zeros? How many zeros have you converted to make this as a 1?
Yes.
That is your subnet bits. Okay, that is basically your subnet bits, and the number of subnets is basically 2 power s. So over here, because we converted 8 subnet bits, so it is 2 power 8.
Yes, sir. Understand.
Got it?
Yes.
Yeah.
Thank you, sir.
Now, let's go to another example. This one. 200.1.1.1. Address mask is 255.255.255.252 is the address mask. Okay. So now let us calculate the total number of ones, or the prefix length or the p bits. Again, okay, total number of ones, the prefix length or the p bits. You have 8 number of ones, 8 ones, 8 ones, and this will is 6 ones. So in total, you have 30 ones in this address mask. Okay, this 30 ones includes your network bits and the subnet bits both. Please remember, this 30 ones or the prefix length includes both your network bits and your subnet bits. Okay, now how to find out the subnet bits? It is basically p bits minus your network bits. So S, we know that p is 30 and network bits 200. 200 is basically a class C IP address. And for a class C IP address, the default number of ones will be 24, the network bits. So the subnet bits or the number of bits it has borrowed and converted it to 1 is 6. Okay, is 6. So you can see here, it clearly mentions 255, 255, 255 is basically slash 30. So P is equal to 30, the number of ones which we calculated over here. Okay, 200 is a class C network. So your network bits is 24, which we calculated over here. So your subnet bits is 6. So your subnet bits is 6, which we calculated over. So the total number of subnets that you can have is 2 power 6. Is 2 power 6. Okay. Then how many hosts you can have per subnet? How many hosts you can have per subnet? That is P, sorry, you have host is equal to 32 bits of IP address minus P bits. So you have 32 minus, you have 30 P bits. So the host is equal to 2. So the total number of hosts per subnet is 2 power h minus 2. So over here, 2 power 2 minus 2, which is basically 2. So each subnet will only have 2 usable IP addresses. Okay, so here we have a 200 network. We have a 200 network. Okay, 200 network. We divided it into smaller subnets. Okay, that is basically 64 subnets. We divided it into 64 smaller subnets. So this is subnet number 1, subnet number 2, 3, 4, 5, 6, 7, like that. There are 64 subnets. And in each of these subnets, there will be only 2 usable hosts in each of these subnets. Here also you have 2, 2, 2, 2, 2, 2, etc. Like that. For each subnet, you will have only 2 usable IP addresses. Okay, why? Because the first is a network ID. We discussed network ID is basically 00, which you cannot assign. And the broadcast ID. Broadcast ID is 255, which you cannot assign to any users. So these two are the -2 that we see in the formula. Clear? Any question?
It's clear.
Clear. Okay. Let's see if we have few. Okay, so we have problems as well. Okay, we have problems as well. So we calculated for this one in the example. Okay, let us try to calculate for the second one. Let us try to calculate for the second. Okay, so we have 130.4.102.1. This is the IP address. Okay, and the address mask is 255.255.255.0. This is the address mask. Okay, that's a pretty simple one. No problem. Let's try to calculate for this one. Okay. So how many p bits do we have, or the total number of ones? We have 8 plus 8 plus 8. We have 24. Okay. How many network bits do we have? Okay. This is a class B IP address. Okay. So we have 16 network bits. If we have 16 network bits, so the S is basically P minus S, sorry, P minus N, which is 8. 24 minus 16 is 8. So we have 8 subnet bits. That meaning 2 power S or 2 power 8, okay, uh, is 256. So we will have 256 subnets, right? Now the hosts, how many hosts do we have? Host bits do we have? 32 minus P bits. So 32 minus 24, right? So giving us 8. That means 2 power H minus 2, 256 minus 2. So we will have 254 usable IP addresses in each subnet, in each of these subnets. So let's check the answer here. 130. Okay. How many P bits are there? 24. We calculated it correctly. We have 24 P bits. We have 24 P bits, which we calculated it correctly. Which class does it belong to? Class B. We said yes, it belongs to class B. In class B, how many network bits are there? 16. So we calculated it right as well, right? How many subnet bits are there? 8. We calculated it right. 8 subnet bits. How many host bits will be there? 8. Right. So we calculated it correctly. We have 8 host bits. How many subnets can be there? 256. Right. So 2 power 8 gives us 256, which we calculated correctly. Then host, how many hosts you can have per subnet? 2 power h minus 2, that is 254, which also we calculated it correctly. So this is how you basically calculate the number of subnets. Okay, the number of hosts per subnet here. Okay, any question understanding this part?
No, sir.
All right. Now, okay, now let's try to find out a problem where it basically tells, okay, how to now the next is the interesting part. How to find out the network ID, the subnet ID of the difficult octets, of the difficult octets. Okay, over here. So for simple networks, okay, or simple octets, let me just okay. So here the first one, okay, 10.77.55.3. Okay, the address mask is 255.248.0.0. We have to find out the network ID, or because we are talking from a subnet point of view, we can call it as a subnet ID as well. Subnet ID and the broadcast ID. We have to find out the network ID or the subnet ID or the broadcast ID for this particular IP address. Okay. Now, if this was a normal IP address with a easy address mask, when I say easy address mask, I mean there is only 255 over here. So for such case, we already know how to find out the network ID. Okay. To find out the network ID in such a case, what we do, wherever there is 255, copy that number as such. Okay. So this is 10.77. And wherever there is 0, just write 0. So this becomes your network ID. Okay. And the broadcast ID. The zeros in this IP address, convert it into 255. This is your broadcast ID. Right? And whatever numbers 10.77.0.1 starting from 0.1, 0.2 up till 10.77.255.253, 10.77.255.254. These are the usable IPs. These are the usable IPs. The network ID and the broadcast ID are the two IP addresses which we cannot assign. Okay, so for simple IP address mask, this is very easy to calculate. But with a address mask like this, how are we going to calculate the network ID and the broadcast ID? This is what we are going to learn now. Okay, now to calculate the subnet ID or the network ID, we will follow the same rule of the easy address mask. Wherever there is 255, copy that value, and wherever there is 0, write 0. So over here, this is 255, so 10. And wherever there is 0, we will write 0. Okay. Now we have a difficult number or a number which is other than 255. Okay. So we have to find out the number over here, and that is what will become our network ID. And to find out the number over here, we will use a magic number 256. Okay. And we will subtract this interesting number or 248 with 256. Okay. Which will give us a value of 8. Which will give us a value of 8. Okay. Now you may ask me why 256? The reason is we have 8 bits, which we call it as octet, correct? Which we call it as octet. And starting from 0 up till 255, including these two numbers, we have 256 numbers. And hence we are using the value 256 to subtract from. Okay, so 256 minus 248 gives us 8. Now, what you are supposed to do is write down the multiples of 8. Okay, write down the multiples of 8 starting from 0. 8 1 8, 8 2 16, 8 3 24, 8 4 32, 40, 48, 54, I forgot the table, my God. All right. So we have these numbers. Now you may ask, till what should I keep on writing the multiples of 8? Okay, so you have from 0, here I have written from 0 to 96. Okay, these are the multiples of 8. And how did we calculate the multiples of 8? By subtracting this number from 256, we got that value. We are writing the multiples of 8. Now, till where should we write? Okay, we will write the multiples of 8 till we come to the number which corresponds to the number 248. In the IP address, the number corresponds to 77. The 248 address corresponds to 77 in the IP address. Okay, now 77 is a number which falls between 72 and 80. The number 77 falls between 72 and 80, and this is where we will stop. So the subnet ID or the network ID will be the number which is lowest of these two. That is 72 in our case. So 72 becomes our subnet ID. 10.72.0.0 becomes the subnet ID for this IP address. For this IP address. Okay. Then the broadcast ID. That is, we know that we'll follow the same rule. Where there is 0, we will convert it into 255. 10 dot here 255.255. But again, what about this octet in the IP address? Can we write it as 255? No. Because 255 anyway does not belong to this particular part of the multiples that we have written. So we cannot write 255 over there. So what number should come in this second octet of the IP address? The number will be the larger of 72 and 80. Here 80 is a larger number between them. So we will subtract one number out of that, 79. So 10.79.255.255 is the broadcast ID for this particular IP address. And let's just check the answer as well. So you can see 10.77. Oh, sorry, no, here. Yeah, 10.72.0.0 is the network ID or the subnet ID, which we calculated it correctly, 10.72.0.0, and the broadcast ID. Okay, we have to find out the broadcast ID, right? 10.79.255.255 is the broadcast ID. All right, this is how we calculate the subnet ID and the broadcast ID for an interesting address mask. Yeah, Naresh.
Yeah, broadcast ID means it is the last IP address, right? So it should be 1080.255.255, right?
No, not 80. 80 is the network ID for the next subnet. Now, since you have asked that question, let me explain you what do these multiples also mean.
Yes, sir, understand.
I'll tell you. So this particular IP address starts from 10.0.0.0. Okay, and it ends at 10.7.255.255. Then it starts with, this is the subnet. This is one subnet. Then the next subnet range starts from 10.8.0.0 and it goes up till 10.15.255.255, which is between these two. Then the next subnet starts with 10.16.0.0 and it goes up till 10.23.255.255. That is between these two. Then the next subnet starts with 10.24.0.0 ends at 10.31.255.255. That is here. So the numbers that we have written are basically the starting of the subnet. Is basically the start of the subnet. It's not the broadcast ID. That is why the IP address that we chose over here, this is the start of the subnet, and it will go up till 10.72.0.0 and it goes up till 10.79.255.255, and this will be 10.80.0.0 and it will go up till 10.87.255.255, and the next subnet, it will start with 10.88.0.0 like this.
Okay,
Got
sir.
it?
Yes.
Yeah. So if people who are listening to the recording, if you do not understand, it's okay. We'll go through few more like calculations, and you will have a better understanding. Okay. Let's go to this one, the next one. Okay. 172.30.99.4. Okay. 255.255.192.0. Okay. Let's find out the network ID. To find out the network ID, wherever there is 255, copy that value. So 172, okay, dot 30. And wherever there is 0, write 0. Okay. So we have 172.30 dot some number dot 0. That is how the network ID would start with. So over here, what we're supposed to do, we're supposed to subtract this difficult number with 256 or from 256. Okay. So 64. So you get 64. Okay. Now we will write the multiples of 64. Okay. So 0, 64, 128 plus 64 gives us 8 plus 4, 2, 192, etc. But we will stop because we want a number. Okay. We are looking for the number 99. And the number 99 falls between 64 and 128. So out of these two numbers, 64 is the lesser one. And hence, we will write this number over here, and this number or this particular ID becomes the subnet ID for this IP address. Okay. And what is going to be the broadcast ID? 172.30. Wherever there is 0, we will write that as 255. But this number over here will be minus 1 of 128. So that gives us 127. And hence, the broadcast ID will be 172.30.127.255. Okay, let's check the answer. See here, broadcast ID is 172.30.127.255, which is what we have calculated. Okay, and the subnet ID is 172.30.64.0, which is what we have calculated. 172.30.64.0. Got it? So this is how you calculate the subnet ID and the broadcast ID for a difficult mask. Let's calculate. Let's try to calculate for one more, and then we will conclude the whole discussion by finding out the P bits, the subnet bits, the host bits, and by calculating the address masks, the subnet ID and the broadcast ID for one of the IP addresses. Okay. So the third one, 192.168.6.54. address is 255.255.255.252, right? So network ID, wherever there is 255, copy that value, 68.6. This is what we have got. Now we need to find out the fourth octet. So 254 minus 252, okay, gives us 2. So we have to write the multiples of 2. Okay, we have to write the multiples of 2. So obviously we will reach till 250, right? 250, 252, then 254. Okay, 252, 254. Multiples of 2, right? Sorry, I'm extremely sorry. I'm extremely sorry. It should be 4, not 254. I was using 256. 256 minus 252 gives us 4. I'm sorry. Okay. So writing multiples of 0, 4, 8, like that, we will reach 63 times. Okay, 256. Okay, yeah. So we will have 248, 252, and 256, like this. Okay, 248, 252, and finally 256. So 240, 244, 248, 252, 256. We have reached till 256. Now 252, 252 is between 252 and 256. Okay. So for this particular IP address, okay, I'm extremely sorry. Okay, I'm extremely sorry. I'm extremely sorry. I was looking for 252, whereas I should be looking for 54. Okay, whereas I should be looking for 54 and not 252. I'm extremely sorry. Okay, so let's go back to our discussion once again. Okay, so 256 minus 252 gives us 4. So we will stop at a number, okay, which will give us a value, which will give us a value where 54 is in between. Okay, so 40, okay, 44, 48, 52, 56. Okay, then 60, 56, 60. All right, now 54 is between these two numbers, right? 54 is between these two numbers. So 52 is lower or the lesser number between 52 and 56. So this will become the network ID or the network ID or this subnet ID for this particular IP address. Okay, and what is going to be the broadcast ID? 192.168.6 minus 56 minus 1, that is 55. So this is a very good example where for a subnet ID, for a subnet ID, 0 is not necessary. And for a broadcast ID, 255 is also not necessary. It is completely based on the address mask that you use. The number may be 0, may not be 0 for a subnet ID. For a broadcast ID, it may be 255, it may not be 255. And this IP address and the address mask combination is a great example. 52 is a subnet ID. It is not 0. Even though it is not 0, because it is a subnet ID, it is not usable. It will not be used. 192.168.6.55, it is not a 255, but it's a broadcast ID for that particular subnet, and hence we cannot use it. So the IP addresses that we can use over here will be 192.168.6.53, 54, and 55.
55 broadcasted.
Sorry, 53 and 54. These are the only two. I thought this as 56. I'm sorry. This is 55. So 53 and 54. These are the only two IP addresses that you can use. So this is a great example of a subnet ID and a broadcast ID which are not 0 and 255 respectively. Okay, and let's just check the answers. Yeah, 192.168.6.52. 192.168.6.52 is the subnet ID which we have calculated. Okay, and the broadcast ID 192.168.6.55. 6.55 is the broadcast ID. Clear of how to find out subnet ID and a broadcast ID for difficult addresses. Any question?
No, sir, it's clear.
Now, in interviews, what they may ask is in interviews or especially in interviews, what they basically ask is, give me the 10th usable IP address for this IP and address mask combination. This is what they ask, and even in exams also, they ask you this question. Give me the 10th usable IP address. Okay, 10th usable IP address for the second subnet. For example, okay, 10th usable IP address for the second subnet. They may ask questions like this. Okay, so what can we do for such scenario? Is the same thing. You have to find out the subnet ID. You have to find out the broadcast ID. Okay, you have to find out how many subnets will be there. And then you have to find out the 10th subnet, okay, or the second subnet or whatever based on the question, and then find out the IP address based on the profile. So let's go to our first question over here. 10.77.55.3, 255.248.0.0. This is the address mask. So they ask, give me the, let's say, fifth usable IP address of the third subnet. This is the question. Okay, give me the fifth usable IP address of the third subnet for this particular IP address and address mask combination. Okay, so Naresh, can you just try to solve this?
Yes, sir.
Okay,
So it is 10
so what's the network ID?
10.8.0.0. 256 minus 248.
Yeah. Okay, 256 minus 248 gives us 8.
Yes.
Gives us 8. Yeah. So
Yeah.
if it gives us 8, so this is 0.0. Okay, so we'll write the multiples of 8.
Yeah.
Okay, 0 to 8, 1 to 8, 8 to the 16, 8 to the 24, 8 4 0, 32. Okay, so this is one subnet, first subnet. This is second subnet. This is third subnet. Okay, so we have found the third subnet. Our third subnet will start from 10.16.0.0. Okay, 10.16.0.0 we have found. And he said, find out the fifth IP address. So it will be 10.16.0.1.
Yeah.
Yeah, 0.1, 0.2, 0.3, and 0.4, 0.5. 1, 2, 3, 4, 5. This is the IP, this is
IP
the
address.
fifth IP address of that third subnet.
Yes.
All right, so this is how they may ask in the interview, and this is how they may ask in the exam. Clear?
Yes, sir. Clear.
Now, to conclude our IP address discussion. Okay, to conclude our IP address discussion. Okay, let's take the fourth. Okay, so whatever we discussed till now, the P bits, the host bits, the subnet bits, and calculating the network ID and the subnet ID, everything. All that, let's use our knowledge of that discussion and put it into use with this IP address. Okay, so they have said 10.77.3.14. Okay, and the IP address, sorry, the address mask is 255.255.128.0. How many P bits are there? Total number of ones. How many P bits are there? Naresh, can you tell me?
Two, sir. 16.
How to?
Sir. 16, 16, sir.
16. Are you sure?
Yes.
Total number of ones. We have 8 ones over here. We have 8 ones over here, and we have 128 over here. We have 1. We have 17.
Yes.
Okay. So total number of ones is 17. All right. Now,
Yes, sir. Right.
if we have total number of ones as 17, now next is network bit. How many network bits are there? This is a class A
Class
IP
A.
address. So we have 8 network bits. Total number of subnet bits, then will be P minus N. So 17 minus 8 gives us 9. 9. Yep, 9. So we have 9 subnet bits. Okay, that is these two. We have 9 subnet bits. How many subnets can we have? We can have 2 power S subnet bits or 2 power 9, which gives us 512. Correct?
Yes, sir.
Now, how many host bits can we have? We can have 32 minus P bits. That is 32 minus 17. Okay, so that gives us 32 minus 16 is 15, 32 minus 17 is 15. Okay, so how many hosts you can have per subnet? It is 2 power 15 minus 2 hosts per subnet. Okay, keeping this in mind, keeping our calculation in mind, now let's try to calculate the subnet ID, the broadcast ID, 10.77.3.14, 255.255.128.0. Okay, yeah, 128.0, right? So now you have 256 minus 128 gives us
8.
120, gives us 128.
Yes.
Yeah, right, gives us 128. Now 0, 128, 256. Obviously, this guy falls between these two.
Yes.
Okay, so our subnet ID will start with 10.77.0.0 and will end at 10.77.127.0. dot 255. Okay.
Yes, sir.
Now,
Yes.
okay, give me a minute. All right. So now this is again a very good example of creating a confusion. Okay. How we calculated 2 power s. We calculated 2 power s to be 512. But here we can see there is only two subnets, 0 to 127 and then 128 to 255. Only two subnets. How can we have 512 subnets? Okay, so let me tell you how it happens. So because it's a class A IP address, your first network octet will remain the same. It will not change. So your IP address starts from 10.0.0.0. And in the third octet, that is where we are calculating the network ID and the host ID, right? Our network ID and the subnet ID, the broadcast IDs of the third octet, right? So from the third octet's perspective, this first subnet will go from 10.0.0.127.255. Then the next subnet will be 10.0.128.0, 10.0.255.255. Okay, then the next subnet. Again, please remember this is one subnet, one subnet, one subnet, one subnet. So you already have four subnets like this. You already have four subnets over here. Four subnets for 0. The next 10.1.0.0, it will go up till 10.1.127.255. Then 10.1.128.0, then it will go up till 10.1.255, sorry, 255.255. So again, you have fifth subnet, sixth subnet, seventh subnet, eighth subnet. Already have eight subnet. So for each of the second octet number, you have four subnets. Not four subnets, two subnets. Sorry. This is not two. This is one subnet, and this is another subnet. This is third subnet, and this is four subnets. So for 0, you have two subnets. For 1, you have two subnets. Similarly, for 2 also you will have two subnets starting from 10.2.0.0, 10.2.127.255. Okay, this is one subnet, right? Then 10.2.128.0, 10.2.255.255. This is the next subnet. So again, you have two subnets. So starting from 0 till 255, how many numbers are there? You have 256 numbers in the second octet. In the second octet, starting from 0 going up till 255, you have 256 numbers. And for each number, second octet number, you have two subnets. And that gives us 512 subnets, and which is exactly what we have calculated over here. And in each subnet, we will have 2 power 15 minus 2 hosts. So this subnet over here that we calculated will have 2 power 15 minus 2 usable IP addresses. He will also have 2 power 15 minus 2 usable IP addresses. This will also have 2 power 15 minus 2 usable IP addresses. And with this, we are coming to an end of our IP address. subnetting, and understanding of IP addresses. What is an IP address? How to calculate the subnets? And I really hope that I have made things very clear and easy to understand. And if anyone do not understand, please do raise your questions on the WhatsApp group that we have created, and it will be an amazing discussion as well. And if you ever have come across any interview questions based on IP addressing, that also we can discuss. All right. So any questions, Naresh? Do you have any question?
No, sir. Clear for me.